Hi, AB Calculus students. We are working on 2019 question number 1. The topic is an ETLT question. Now, this is a graphing calculator question. They could ask a similar question on the AP exam this year, but you'd be able to solve it without a calculator, because in case you don't have one. But for this one, you definitely want to have one. If you don't have one, look at the setup. If you can set it up, maybe you can't finish the questions, but Desmos.com should actually help you with a lot of what you need here. But if you don't have a great graphing calculator to finish, no big deal. Just set it up and see how close you can get to finishing it. So first of all, this is the ET, the rate that fish are entering, and I put it in Y1. And then this is LT, the rate that fish are leaving, and I put it in Y2. So let's go ahead and start with part A. And part A said how many fish enter the lake over the time period from like time equals 0 to time equal 5. Well, the amount of fish that enter are whatever is underneath this entering rate. So this is it. Now, of course, ET, you can either write this whole, I just write ET to ET because they're given points for writing this down. They need to see this. So that's points right there. If you want to write that whole thing out, that's fine. Just make sure it's in parentheses before you put the DT at the end. And if you're going to use your calculator, like you should, use hotkeys. If you've already put this in Y1, use the hotkeys, put a Y1 in there. And when I type this in the calculator, obviously I'm just trying to speed up here, so I'm not typing it in my calculator. I'm just going to tell you the answer. So you get 153.457, 153.457.6. But here they ask you to round to the nearest whole number, so it's 153. Okay? And that is part A. It doesn't matter what I race with, it never works. Okay. Now let's go to part B. Now part B, if you're watching this and it's the COVID-19 year, part B won't be on the test, because they ask you for the average number of fish that leave. Now, this right here is not what we're using. The slope formula, this is the average rate of change. You will notice they don't ask for the average rate of change, they ask for the average number of fish that have left. Okay? So it's very, very important. They specifically have to say average rate of change. Average anything else is the average value of a function formula. Okay? So average rate of change specifically means slope through the endpoints. Average anything else is this formula. And again, if this is your year taking the test with the whole COVID-19 thing, this can be on your test. This cannot. The 1 over b minus a, you will never have to put a fraction in front of the integral. Okay? So anyways, let's go ahead and solve the question. So 1 over b minus a, they say on the time interval 0 to 5, so 1 over 5 minus 0. Integral 0 to 5, and it's how many left. So it's the average formula for the amount that left. And again, when you get to LT, I just use my hotkeys Y2, or you can just write that into your calculator, and we're going to plug it in here, and you get 6.0 590. And that's it. So that's part B. And now we're going to go to part C. All right. So for part C, they want to know, when will you have the greatest number of fish in the lake? And an interesting thing happens here. They actually never tell us the initial amount. We don't know how many fish they're started off with. But you don't need to know how many fish there are to start with to know when you have a maximum. They didn't ask what is the maximum number of fish. They asked when will you have a maximum. So here we have our cup of water again. ET is the rate that you're pouring things in. LT is the rate that things are leaking out. So when there's more entering than leaving, the amount goes up. and then when there's more leaving than entering, the amount goes down. So if we want to know in this question, when is it at a maximum, we have ET is greater than LT, so the amount's increasing, and then it changes and LT is now greater and the amount decreases. And this is the maximum time. So I need to know when does it hit this maximum. And again, this maximum is when ET and LT are equal. Our critical points occur when the entering rate and the leaving rate are equal. So when ET equals LT, or I prefer it this way, when ET minus LT is equal to 0, that's when we're going to have critical points. So I'm going to do this. Now, how am I going to do ET minus LT? Well, I don't feel like retyping this one minus this one. And I'd have to be careful when I do minus this one. All of this would have to be in parentheses, so the minus sign would belong to everything. So what I'm going to do in my calculator, and again, if you don't have a calculator, go to Desmos.com, graph this, and then this. And then you're just trying to find out where they're equal and find out where they intersect. But anyways, I'm going to graph this. ET is in Y1. So I'm going to use the hotkeys and put a Y1 here, and then use the hotkeys in a Y2, so I don't have to retype all this. And I want to know when will this equal 0. So I'm going to graph Y3. I'm going to turn off the graph of Y1 and Y2, and I'm going to graph only Y3, which is these two being subtracted. So I'm going to subtract this one minus this one and graph it and find out when it equals 0 by using the 0 button on the calculator. And when I do this, I will get time equals 6.20356. Now, how do I prove that this is the absolute maximum? Or when there's an absolute maximum on the time 0 to 8? Well, I'm going to make a quick sign chart for ET minus LT. Remember, ET minus LT is my net rate. So it's equal to 0 here. And now I want you to look at the graph. You will notice the graph has positive values, and then it hits 0, and then it goes down. It has negative values. So you will notice positive values when ET minus LT is greater than 0, or when ET is greater than LT, the amount increases. So that means the amount goes up, and then the amount goes down. So this is when the absolute max occurs. So if you look online, I'm just going to read out to you what's online, okay? I don't feel like writing it all out. But it says ET minus LT is greater than 0, or positive, from time 0 to time 6.20356. And ET minus LT is less than 0, or you could say negative, from time 6.20356 to time 8. Therefore, the maximum number of fish occur at this time. And that's it for part C. All right. So now let's go to part D. The first time I've read this question, I answered it the wrong way. I did. I looked at the answer and I would have gotten 7 out of 9. And I couldn't believe that I messed up. Now, here is what I did. I looked at ET and LT. And we've talked about this before. If ET is greater than LT, if the entering rate is greater than the leaving rate, the amount is increasing. If things are entering faster than they can leave, the amount of fish is increasing. And if it's the other way around, if ET is less than LT, meaning the leaving rate is greater, then the amount is decreasing. And so this is what I did. And this is wrong. I plugged, it says that time equals 5. I plugged the 5 into both of these and looked at which one's greater. And then I use that to say, oh, this one is increasing or decreasing. And that's wrong. Because, you need to hear this, because this will tell you when the amount of fish is increasing or when the amount of fish is decreasing. Nobody asked, is the amount of fish increasing or decreasing? Read the question. Is the rate of change in the number of fish? Another word for rate of change or instantaneous rate of change is the derivative. Is the rate of change increasing or decreasing? If they said the amount of fish, this would tell me if the amount of fish is increasing or decreasing. But we want to know the rate of change of the amount of fish. So we want to be learning about its derivative. So unfortunately, we're going to have to do this and look at e prime like that. We're going to have to look at the derivative. Since we're not wanting to know is the amount of fish increasing, we're wanting to know is the rate of change of the amount of fish increasing. So to learn about the rate of change, you have to look at its derivative to find out if it's positive or negative or increasing or decreasing. So that's exactly what I did. Now, I have to take the derivative of this and plug in time 5. And then I got to take the derivative of the other one and plug in 5. But I'm not taking the derivative by hand. So what I said is I said e prime 5 equals, and then I just have the answer here. Oh, I got to look it up because I'm not typing it in my calculator. So here, e prime 5, oh, I don't even know what it is. They don't even tell me. Whatever. You get some number. And then L prime 5, and you get some other number. How am I going to do this? I don't want to do this by hand. So in your calculator, you would do the derivative, math 8, and then you would plug in y1. So you're telling the calculator to take the derivative of y1, take the derivative of vt, and then plug in 5. And it will give you some value. And then I'm going to do the same thing for the next part. I'm going to take the derivative of what's in y2 and ask the calculator to plug in 5. And it's going to give me some other value. And if I compare them, you will see that e prime 5 is less than L prime 5. You can check those out, and that's which one's going to be greater right there. So anyways, because L prime 5 is greater, the leaving rate, the rate of the leaving rate is bigger than the entering rate, then you would say it is going to be decreasing. And here, of course, it's the rate of change, because I'm trying to say what they want. The rate of change of fish is decreasing at time equals 5. And again, this is my justification. So part D was really just tricky because it's so different. It seems worded so close to what we've seen before, but just that little twist. They didn't want to know is the amount of fish increasing or decreasing. They want to know is the rate of change, or the derivative of the amount of fish increasing or decreasing. All right, that's the end of that video. Thank you so much. Bye.